Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area green square? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. 6 squares locked together around one tiny blue square. Its area is the only number we are given. Can that single fact determine the area of the green square? The area formula is immediate once we know one green side. So the real geometry question is how the surrounding squares determine that side. We will use the familiar square area rule in both directions. Area gives side by a square root, and side gives area by squaring. The 4 is centered inside the small blue square, so it represents area, not a side length. Run the square area rule backward. The blue side is the positive square root of 4. So every side of the blue square has length 2. That small length becomes the step size carried through the packing. First insight, call the short leftover gap x. Watch the equal square sides carry the 2-unit blue side through the packing. The successive white sides become x plus 2, x plus 4, x plus 6, and x plus 8. Each move adds exactly one blue side, which is 2. The labels stay on their own square sides, so the algebra and picture remain linked. After 4 transfers, the full side of the largest white square is x plus 8. We still do not know x, and we do not need to. Second insight. Now compare the longest white side with the green side. The remainder x cancels from x plus 8, leaving the green side equal to 8. The unknown disappears without being solved. The packing has now done its job. One side of the green square is 8. Return to the square area rule. The green area is its side squared. Substitute the side length 8. Only one multiplication remains. 8 squared is 64. The green square has area 64 square units. The memorable move is not the final squaring. It is recognizing that the same unknown gap appears twice and cancels. Geometry often becomes simplest when we compare lengths before solving for every unknown. So the final answer is 64. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.